I'm good. Okay, so this is the fourth Practice of Science lecture for this year, and our today's guest is George Andrew Olah, and I'll just give you a really brief introduction. He was born in Hungary in 1927, and 30 years later he moved to North America. He's been living here for 55 years in this country. During his magnificent career, he has collaborated with more than 200 graduate students and postdocs. And in 1994, he was awarded a Nobel Prize for his research in chemistry related to the discovery of stable carbocations. And those species were known to exist as intermediate species, in certain reactions, but were never actually formed in a stable form. And the legend says that, and Dr. Olah will confirm if that's true or not, that one of his postdocs actually placed a candle inside a superacid and noticed that the candle got dissolved, which actually signified that superacids, which are acids, could be like billions or trillions times stronger than conventional mineral acids, essentially broke down the covalent bonds between carbon atoms. In that process, they formed those exotic species that are named carbocations, like protonated methane, for example. And however, today he switched his interests. Dr. Olah is today the director of Locker Hydrocarbon Research Institute, which is within University of Southern California in Los Angeles. And he is propagating the concept of methanol economy, which is an alternative to hydrogen and ethanol economy. The basic idea is that carbon dioxide from the atmosphere could be transferred into methanol, which could be conveniently used as a substitute for fossil fuels. Could you please welcome George Olah?
It's a great pleasure here with you, and I don't travel much and I don't accept invitation except from students. And I don't know exactly what you expect from me, but for better or worse, I'm an outspoken guy. So besides science, you will hear some of my opinion. Don't take it too seriously, it's my opinion. I think the trouble with scientists, like most other people, if they get some recognition, many of them start to take themselves too seriously. Now, I take my science very seriously, but I don't take the trimmings too seriously. So I appreciate your invitation, and maybe I could have gotten here even connected with some work which has some interest to you, because what I am going to talk about, what I am interested now, has very little, I think, scientific interest for most of you, except that, like all human beings, you are also using a lot of energy, and I'm not going to do anything about energy. I am not an energy producer or researcher. My interest presently is how you store energy, transport and use it in renewable new ways. And I guess, for example, all of you drive cars or use cars and so on. So I guess, for example, you must have some interest what fuel you are going to use. Will there be enough fuel at a reasonable price? And as citizens of this planet, we are also concerned that we should carry out our activities and life in a way which is compatible with the environment and which isn't doing too much harm to the environment. Now, be careful on this, because there are limits on this. You may hear these days a lot about the one particular element I am involved for a lifetime, besides others, and it's the element carbon. Now, I guess most of you had some type of a chemistry course or background, so you know that our planet and our universe are built up from a limited number of building blocks called elements. And one of them happens to be carbon. And most living matters contain carbon. Therefore, the chemistry of carbon was used to called organic chemistry. So, character like me, who work in this area of carbon chemistry, are generally called organic chemistry. I don't like classification. It's very difficult to classify or hyphenate things. It's very popular, but it's very difficult. You will hear a lot what I will tell you about one very simple compound of carbon, carbon dioxide. Now, is carbon dioxide really an organic compound? It's very difficult to say. It really is formed by processes. If you combust or burn any carbon-confirming compound, which includes a lot, look, all living creatures, including us, boil down to a limited number of elements. An average weight human being has maybe a pound or a pound and a half carbon in it. And eventually, when we disease, and they are disposed of by natural or religious or other technical means, all of our carbon content form carbon dioxide, and that's what's released in the atmosphere. On the other hand, carbon dioxide is not considered an organic compound. Organic compounds generally are considered, I guess, compounds which contain, besides carbon, hydrogen, which we call hydrocarbons, and throw in a few other elements. Now, why is this carbon-centered world of particular interest, besides the aspect of life, species, and so on? Incidentally, I have some credential which I won't mention too much. I started my scientific career as the scientific grandson of Emil Fischer, who was a reasonably well-known chemist of his time. When I said reasonably well-known, he got the second Nobel Prize ever awarded in 1902. And Emil Fischer single-handedly created bioorganic chemistry. I would go a step further, even biochemistry. His studies on carbohydrate, proteins, even his concept of the lock and key theory of enzymatic interaction was the foundation of what had grown into an enormous, important, and still fascinating field, which I guess one day or other you all are practicing and involved in. Now, the funny thing is with Fischer that late in his life, he then gave away biochemistry. And he wrote a few papers and gave a few lectures explaining why. And what he said was that a decent chemist, whatever decent is, shouldn't deal with compound which he or she can't isolate, purify, crystallize, and properly analyze and determine. Now, at the time, there was no spectroscopy, practically no separation methods. What chemists did, they isolated compound and then they did combustion analysis, which one of his student officials, a gentleman called Prelog, invented, for which he also got a Nobel Prize. This was combustion analysis. And all people growing up in the Fisher School did this. Believe me, it was not great fun. And you even questioned the silliness. Why should you do a combustion analysis, which is more or less a technical, boring process? But it had advantages. You learn certain things, for example, the absolute necessity to isolate, purify, and get your compound in poor shape. Otherwise, this analysis means absolutely nothing. So anyhow, Professor Fisher was a very interesting character. And he probably turns in his grave because some of his followers at the centennial of his Nobel Prize, they published articles, lifted his family tree. I'm even listed there as one of Fisher's notable, whatever, recognized family members. But the point is that I got away from his shadow, but I always felt it's greater fun to do something you are interested in. Now, his son also got away from his father's shadow. And I think around 1920 he came to Berkeley, of all places. Now, this was to get away as far as possible from Germany. There was no airplane traffic at the time, so if you really wanted to get away far, this was as far, probably, the other side of the world. I talked to a similar group of graduate students at Berkeley yesterday, and I even asked some of their faculty. None of them ever heard about Professor Fisher, who was a professor of organic chemistry for 30 years in Berkeley. But it's okay, I mean, fame or recognition is very short-lived, and probably it's all right, but the simple matter of fact is, I always found it's more fun to do certain things you are interested in than things which a lot of other people are interested in done already. And even as a young graduate student or then a young faculty member, I had a hell of a time first with my advisor, who was a Fisher student, and then with the pals who in all places run the show. You know, there's a very funny thing about it, and some of you will go in academic careers, and you rely on grants. You all need support to do some work. And when you write a proposal, it's my limited experience. When you write a proposal and ask for support, this goes before a committee. And if you suggest something which is in the main line of things, and the members of the committee maybe themselves well-known practitioner, or at least have heard about it, hopefully they'll approve your application. On the other hand, if you really have some ideas on your own, which nobody really was interested or studied with, then life isn't always so easy. This goes even further. And what I am telling you today is it's really, I own a great degree of gratitude to NIH, and even to NIH former director, whose name I won't mention, because, you know, in 1994, a number of interesting things happened to me. One was that after, I think, 30 years, NIH discontinued my research support. And I got a letter which it said that the study section looked at it, and they felt that at my age, I certainly won't do any further meaningful or interesting work, and therefore it's their judgment that there's no justification for continued support. And then about 6 weeks later, I got a wonderful letter from the director of NIH, who said that how delighted he is to be able to congratulate me and pointing out that my work was supported and is supported by NIH. Now, when you get these two letters, you come to some conclusion. What happened in between that the Swedish Academy gave me a prize. But it's okay, we are all human beings. It's very nice that you get some recognition occasionally. It shouldn't go in your head. And why I'm grateful to what I said is that I am a reasonably stubborn and proud individual. And when you are told that you are really past any ability to do any meaningful work anymore, and you practically should be put on the shelf, I felt the hell of it. I still had, at least I felt, some mileage to go. And I changed field and got interested in other things. And that's what I'm going to tell you a little bit. The conclusion is never gave up. And life isn't easy. Look, even when you get some recognition, don't feel that this makes your life easier. In many ways, it makes your life much tougher. I'm sure some of my friends enjoy recognition. You can travel the world, you can pontificate and impress people. But if you are really genuinely interested in science, and I don't know why I'm interested in it, but I am still, despite my age, it really doesn't matter so much. It matters more that if you do some research on ideas, and ladies and gentlemen, I still have a lot of ideas, and I had a lot of ideas in my lifetime. Most of them never worked out. Now, you have this feeling that particularly somewhat successful scientists, when they write about their life, you read these things that at age 12 I was already sure that I should dedicate my life to make some discovery for the benefit of mankind, and I am doing this ever since. In my limited experience, this is hogwash. What drives, I guess, scientists is mostly curiosity. You are interested in something. Now, things changed a little bit. Now, even in science, money came more important. A lot of my friends who did some work which they or others felt has some practical use started companies. And some of them even became rich, which is fine. It's wonderful to have friends who are well off financially. It's a hell of a lot better than if they are broke and come to see you and say that they need some bailout. On the other hand, you see, you have just one life. At least I couldn't figure myself running a business or a company and at the same time enjoying science in the way that you do it curiosity driven. I have nothing against people who make money. I happen to believe that our system, with all its shortcomings, is still better than many alternative systems. But you have only one life to live. You must decide what you want to do. And I must tell you that I had a very happy and rewarding life. I did most of my life what I love to do. I tell you honestly, I'm even now surprised that they even pay me something to do this. Now, how many people can say that they are doing something which they enjoy, which they would try to do anyhow, and they even make a living out of it? Now, why I'm saying this, I will stop here to be philosophical in any way, but I just try to tell you that how I got involved with this particular problem and why I spent the last 15 years working harder than ever in my life on something which most people, honestly, I don't think, so makes any sense whatsoever. And I will tell you a little bit, that some aspect of it is getting now recognized or used around the world. Unfortunately, not yet at home in the US, but, you know, we once were leaders in technology in the world. I am not so sure, unfortunately, that in many fields we still are. The best argument, at least in my limited experience, if you try to get involved, which has also practical implication, is that others are already doing it. That's a powerful argument. If nobody is doing it yet, people are very suspicious to give you support or invest in whatever you are doing. But if some others are already doing it, then they take you somewhat more seriously. On the other hand, I just told you that there is more fun to do something new than to follow the crowd. Now, I never was a mountain climber, but supposedly, if there is a very difficult mountain peak, to climb it the first time is a great experience, and you get even recognition for it. The first guy who climbed Mount Everest is remembered forever. I guess there was hundreds or thousands since. Some died, some managed, but anyhow, nobody remembers them anymore. So running with the crowd, I guess it's relatively safe. On the other hand, if you try to do something which is interesting to you and you believe in it, I am not saying that you should put all your marbles on it. But if you start a career and you have some support, you know, support is a very funny thing. It's recorded, but anyway, at my age, what can happen to me? Once you got support, to get support is tough. Once you got support, then really there isn't very close supervision what you have done. There are people who can write wonderful proposals, proposing all the wonderful things what they would do if they are given the financial means to do it. And some of them do it. Not all. As a matter of fact, I think the majority are not. But this is not particularly in the limelight. I tried during my life to make some excursion and suggestion. Many years ago, I suggested, I even wrote letters about it in publication, that young researchers should be trusted when they start their career and given support. Look, after all, you have gone through a long educational process, you achieved degrees, you worked at good places, and eventually some institution hired you, say, as a junior faculty member. Based on this, I said, you could be trusted to giving some support, say, for 5 years. And you know what you try to do. A committee may look at your proposal on the terms I just told you. If you support something safe, in line with general accepted practice, you may support. You really try to suggest something unusual and new, you have big trouble. I would trust the young researcher, but after the period of time, say 5 years, then I think a committee should have a hard look and say, has this person really done something? If he or she did, I think continued support is needed. If she or he didn't, they should try something else. Now that's what I'm simply saying is that when you start your career, be prepared that life isn't always very easy, but it's probably is good. If we have some challenges, sometimes it's very helpful. On the other hand, it's better to keep a balance and have a reasonable situation where you can still do your work without spending most of your time of fighting for support or fighting bureaucracy. So anyhow, now, having distracted you with some personal remark, let me tell you what I did in the last 15 years and why I think this has some meaning.